Hello everyone, welcome back. This is Engineer Hussein Mwasapi. Alright, so in this video we'll be looking at what is known as functions, and we'll have different objectives that will follow under functions. But to be precise, let's define what a function is. Now, if you look at functions, you need to understand one thing, that a function is regarded to be a set of inputs and outputs. Set of inputs and outputs. The inputs are regarded to be the x values, while the outputs are regarded to be the y values. So if we try to use an analogy of a machine, say we have this like that, going out like that. So suppose that whatever I'm trying to put in this machine is my set of inputs, and these are the x values. Say x starting from 1, 2, 3, 4, and it keeps on going just like that. Then if this machine right here is my function, then I can define this function to be something. I can call this maybe f of x being defined to be 2x. Now whatever I get out of this machine, which is my function, is regarded to be my output, which are the y values. Now if I get the first input and put it there, what will be my output value? So let's try and understand that. So since a function is a set of inputs and outputs, at x is equal to 1, my function is defined at y to be, if I put 1 there, if I put 1 here, like that, what will happen? I have 2 times 1, isn't it? And that will be 2. If I define it at 2, if I put 2 where there is x, what will happen is I have 2 times 2, and that will be 4. If I put this 3 where there is x, I have 2 times what? 3, that will be what? 6 and 8, and it keeps on going just like that. So this is what I mean when I say it's a set of what? Inputs and outputs. Now, what you need to understand that under functions, there are several objectives that we have. So let's try and look at these objectives. Now, the first objective will be learning how to find the function of what? A number. Now, when I say learning how to find the function of a number, it simply means that we're learning how to evaluate a function at a certain point that has been given. Let's say we're trying to define or evaluate our function at an input where we have x is equal to what? 1. If the x values, which are the domains, are given, it's easy for you to find out the output values, which are the what? The range values. Now, let's understand this with what? Examples. Alright, so say we're being given a function given, let me just say given that f of x is equal to 2x plus 1. Then, let's say for instance, we are asked to find a f at 2. So basically, for us to find f at 2, all we have to do is to look for the function that defines what we have here. And this function is the f of x function. So we have f of x being equal to what? 2x plus 1. Now at an input value of 2, what will be my range value? Because f of x is y at a given value of x. So wherever there's x, I'll put what? 2. So I'm looking for f at what? 2. And this is equal to 2 times 2 plus 1. If you evaluate this, f at 2 will simply be 2 times that is 4 plus 1, you get 5. So that's what you get. If at all we're given to say we have to evaluate this at f b at minus 1, so f at minus 1, we can just get the f of x function, which is 2x plus 1, then define it at minus 1. So f at minus 1 is equal to 2 by minus 1 plus 1. F at minus 1 is equal to 2 times that, you get minus 2 plus 1. Different signs, what do? You subtract. But your answer will always have the sign of the bigger number. So minus 2 plus 1, that's minus 1. So that will be our final what? Answer. Now suppose we had another question where it say given, write it properly, given that f of x, let me call it different, let me define it to be a different function. It's a g of x is equal to 3x plus 1 over 2. If at all I've been told to say find, for instance, g at minus 4. We have to look for a function that is defined by g, and that's the g of what? X function. And that is equal to what? 3x plus 1 over 2. Now g at minus 4 simply means that wherever there's x, I put minus what? 4. This will be over what? 2. This 3 multiplies the minus 4, so g at minus 4 is equal to 3 times minus 4, that's minus 12 plus 1 over 2. Therefore, g at minus 4 is equal to minus 12 plus 1, you get a minus 11 over 2. And that will be your final what? Answer. Say we've been told to evaluate at g of 7. So now g of 7, we have to look for the g of x function, which is g of x being equal to 3x plus 1 over 2. Then after that, define this g of x at the given input value, which is 7. So g at 7 is equal to 3, wherever there's x, I put 7 plus 1 over 2. So g at 7 is equal to 3 times 7, I give you 21, plus 1 over 2. So g at 7 is equal to 22 over 2. Therefore, if you simplify this, you will get 11. Because 2 into 22, that is simply 11. Now, other problems that we might come across might involve certain aspects that have other related conditions. Let me just give you a review of something. If you remember, according to our decimal rules, if I have a point b, this is the same as one having ab over what? 10. We just remove the decimal point and then check the place of the number after the decimal. So mostly I like to say remove the decimal point, write whatever you have, and say over 1. Then the number of zeros will be dependent on how many numbers you have after the decimal point. Since I'm only having 1, that's why I'd put 1 0. If I have a point BC like that, I will just remove the dot and I'll have A, B, C. And this will be over, I will put 1. Then the number of zeros will be dependent by the number of values I have after the decimal point. So I'm having 2 of them. So this will be 0, 0. So I have converted a decimal fraction into what? A single fraction. That's what's going on there. Converting the decimal fraction into a single what? Fraction. So even here, we converted the decimal fraction into what? A single fraction. We can also look at maybe a scenario where you have A, B, point, C, D, E, F. You can always pause the video and attempt to do this question on your own. Now, if you try and convert this, you will have A, B, C, D, E, F over, because I've removed the decimal point, then I'll say 1, and it will be over the number of values I'm having after the decimal point. I'm having 1, 2, 3, 4. So it's going to be 4 zeros. 1, 2, 3, 4, like that. So that's just a quick review of something I want you to know. Now, let's say we have another example. Example 3, given that f of x, I'll use the same functions I was using, is equal to 2x, where is that? 2x plus 1. Then we're being asked, let's say, to find, A is saying find something as f at 2.4. So now all I have to do is look for the function that defines f, which is f of x. F of x is equal to 2x plus 1. Now f at 2.4 simply means wherever there's x, I'll put what? 2.4. Then plus 1. Now it's very difficult if you're always been told not to use the calculator. It will be a bit difficult for you to evaluate this. So 2.4, you have 2. Convert the 2.4 into a single fraction. This will be 24 over what? 10 plus what? 1. Others would also want to reduce this. You can reduce it if you want. But let's just leave it that way. So I can also reduce by saying 2 there. That is 1, 2 there, and the like. Or we can just go directly and just say, okay, what is 2 times 24? Now, f at 2.4 will then be 2 times 24. That will be 48 over what? 10. I prefer not reducing so that you can just take it back to the decimal fraction easily by maintaining the 10 at the bottom. So like this, it implies that you have f at 2.4. Now, let's convert back the 48 over 10 into a decimal, and that would be 4.8 plus 1. Therefore, f at 2.4 is simply just going to be what? 5.8. Just like that, to be 5.8. Alright, now the second objective, which is objective 2, will simply be learning how to find the function inverse. So let's look at how we can find the function inverse, where we say to the power of a minus 1 of what? X. Be mindful of that. So we're saying function inverse of x. Alright, so now how do you go about finding the function inverse of x? Let's understand this with some examples. So the first example states that it's given that let's say we have f of x, a function, to be 2x plus 1. Then suppose we're asked to find f inverse of x. This is basically the function inverse of x. So all we're supposed to do now is to first determine what we need. We need the function inverse of x. So now, for us to find the function inverse of x, we need to look for the function that defines this inverse, which is the function of x. So my f of x is equal to 2x plus 1. After that, the second step, is where I have to let f of x equal to any letter of my choice other than x. So in my case, I'll use y. So now this entire thing here now is going to be y. So this is going to be 2x plus 1. So we're having y being equal to 2x plus 1. After that, the second stage is to make x a subject. Now, making x a bit of formula simply means that isolating x. So now this can also be written as 2x plus 1 being equal to what? Y. You make x subject, the plus 1 goes the other side, and you have 2x being equal to y minus 1. Divide both sides by 2, you'll be having x being equal to y minus 1 over 2. Now, after you do that, all you're supposed to do is to substitute. So substitute f inverse of what? X. And wherever there is y, put what? X. Therefore, we say f inverse of x is equal to, where there is y, I put x, x minus 1 over 2. So that is the inverse. Let's look at another example. Say we have another example that says, find g inverse of x, let me write it properly, g inverse of x, given that g of x is equal to x minus 7. So you can always pause the video and attempt to do this on your own. So all we're supposed to do is understand what we're looking for. We're looking for g inverse of x. So you need to find a function that defines the inverse, which is g of what? X. G of x is equal to x minus what? 7. So now, once you define that, all you're supposed to do is to let the function you have, in this case g of x, be equal to any letter of your choice. In this case, I put y. But be mindful that that letter should not be x. After that, this entire thing becomes y being equal to x minus 7. After that, you have to make x subject of formula, make x subject. So I can flip this and I have x minus 7 being equal to what? Y. The minus 7 goes the other side and becomes a plus 7, so I have y plus 7. Therefore, after that, all I have to do is substitute. Now remember, we're looking for the g inverse of x, so g inverse of x is therefore equal to, wherever there's y, I plug for x. So x plus 7 will be the inverse of the g function. Alright, let's look at the last example on the function inverse of x. Okay, so suppose we have 3 that says that it's given that h of x is equal to, let's say 3x plus 1 over 2. And then we need to find h inverse of x. Remember the steps. You can always pause the video and attempt to do this on your own. Alright, let's do it. So we need to find h inverse of x. The function that defines the inverse of h is the h function, which is h of x. H of x is simply equal to 3x plus 1 over 2. At this point, the next thing we're supposed to do is to let h of x equal to any letter of our choice other than x. So we let it equal to y. So this entire thing here becomes what? Y. So y is equal to 3x plus 1 over 2. Now, all we're supposed to do now here is to make x subject. Alright, now making x subject of formula simply means I'm having y, this will just be y over 1 being equal to 3x plus 1 over 2. You do your cross multiplication, you have 2 times y being equal to 1 times 3x plus 1. 2 times y gives you 2y. The 1 times anything will not change anything. So I have 3x plus 1. I can flip this equation and I have 3x plus 1 being equal to 2y. Then I'll solve for x by causing this plus 1 to go the other side. So I'll have 3x, this goes the other side, like that, and I'll have 2y minus 1. Now, we're not looking for 3x, rather, we're looking for x. So I have to divide both sides by 3. X is then equal to, remember, 2y minus 1 over 3. Then we can also substitute this by now saying h inverse of x is now equal to 2x minus 1 over 3. And that is your answer. Now, at times, I did make mention it's the last example, but I feel like I have to explain just one example. I want you to understand that at times, let's say, you might be given such a problem. Given that p of x is equal to 4x plus 1 over 3x. Then I say find p inverse of x. Alright, so all you're supposed to do here is to remember that we have to now look for what, to understand what we're looking for. We're looking for p inverse of what? X. That's what we're looking for. Now the function that defines the inverse of p is the p function, which is p of x. Alright, properly p of x, which is equal to 4x plus 1 over 3x. Now, once we reach this point, all we're supposed to do is to let p of x equal to any letter of our choice other than x. So we let p of x equal to what? Y. So this portion here becomes y being equal to 4x plus 1 over 3x. Then after you reach this point, make x subject. Now making x subject of formula, I'm having y, already this p over 1 being equal to 3x plus 1 over, 3x, but 4x plus 1 over 3x. Then you do a cross multiplication of 1 times 4x plus 1 being equal to 3x times y. Then this one multiplies everything, but remember 1 times anything will not change anything. 4x plus 1 is equal to this times that gives you 3xy. Remember now we're looking for the value of x. So having 4x plus 1 being equal to 3xy, all I can do is to put the x's on one side of the equation. So you have 4x, this will go the other side, and you have minus 3xy. And now the plus 1 will go the other side, and you have is equal to minus 1. So now that you have this, you can factor out the x, and you have x. If you pull out the x from there, you have 4 minus 3y. That is going to be equal to minus what? 1. Now, since we're looking for x, having x open brackets 4 minus 3y close is not the final answer, so we divide both sides by what we have in our parentheses, and this would be 4 minus 3y. So that cancels with that, and you have x being equal to minus 1 over 4 minus 3y. Therefore, when you substitute, remember p inverse of x, wherever I see y, I put x, minus 1 over 4 minus 3x. So that's the final answer. Now be mindful that finding inverse functions, most cases you find that people will find or have different expressions of the inverse of that particular function. In most cases you end up finding two different answers. Another person would do the same procedure and find a different answer, as well as another could do a different procedure and find another answer. But if you evaluate that function at a certain value of input, you will get the same value. So be mindful about that. It doesn't necessarily mean that you're wrong. It just means that maybe you the approach you used was different, but it's the same technique. Maybe the terms were taken to the different side, you did something else. It basically deals with the way you logically think when it comes to computation in math. I hope that's clear. Alright, so let's move on to the third objective, finding the function inverse of a number. Okay, so we're looking for the function inverse of a number, like that. Alright, so let's also understand this with an example. So basically you might have an example where I would say, given that f of x is equal to 2x plus 1. Say you've been asked to find f inverse of 2. So we have two methods. Method 1, find the expression for the f function inverse of x, or simply find the function inverse of x first. So by doing that, it means I have to look for the function inverse of what? X. So I get my f of x being equal to 2x plus 1. Then after that, what I have to do is I'll let my f of x equal to y. Then I'll have y being equal to 2x plus 1. Then after that, all I have to do is make x subject to the formula. I can flip the equation. I have 2x plus 1 being equal to y, and I have 2x being equal to y minus 1. Then I divide both sides by 2. By 2, I have x being equal to y minus 1 over 2. Therefore, what we get in the end is the function inverse of x being equal to what? X minus 1 over 2. Now, in method 1, once you find the function inverse of x, so we know that the function inverse of x is equal to x minus 1 over 2. All I can do is to evaluate this same function inverse at the input value, which is 2, which means wherever there is x, I'll put 2 minus 1 over 2. So the function inverse of x, of 2 is equal to 2 minus 1, that's 1 over 2. Now when it comes to method 2, all we're supposed to do is simply first get the function that defines the inverse, which is f of x. F of x is defined as 2x plus 1. Now to find f inverse of 2, all we're supposed to do is to let f of x be equal to the number given, which is 2. So this means that this guy becomes 2, and this is equal to 2x plus 1. Once you reach this point, all we're supposed to do is solve for x. So you have 2x plus 1 being equal to 2. This goes the other side, and you have 2x being equal to 2 minus 1. So you have 2x being equal to 2 minus 1, that's 1. You divide both sides by 2, and you simply get x being equal to 1 over 2. And that's simply the same as the value that we got here. So that's another method you can actually use to find the function inverse of a particular number. Okay, so now let's try and look at another question. Okay, so given g of x being equal to 3x plus 1 over 2, say we've been asked to find g inverse of, let's say, minus 4. Alright, let's solve this. So you can always pause the video and attempt to do this question on your own. Alright, so method 1, we get the function g of x being equal to 3x plus 1 over 2. You let the function, which is g of x, equal to what? Y. Then you have y being equal to 3x plus 1 over 2. You solve for x, you have 3x plus 1 being equal to 2y. Make x subject, you have 3x being equal to 2y minus 1 divided by 3 divided by 3. You have x being equal to 2y minus 1 over 3. Therefore, g inverse of x is equal to 2x minus 1 over 3. Then evaluate the g inverse at the given input, minus 4. This gives you 2 times minus 4 minus 1 over 3. Then you have g inverse of minus 4 being equal to this times that's minus 8 minus 1 over 3. So I have g inverse of minus 4 being equal to minus 9 over 3. Then g inverse of minus 4 will simply be minus 3. When it comes to method 2, all we're supposed to do is simply just let g of x equal to the input value, which is minus 4. So you get minus 4 being equal to 3x plus 1 over 2. This would be over 1, cross multiply. You have 3x plus 1 being equal to 2 times minus 4, that's minus 8. Then the 1 goes the other side, and you have 3x being equal to minus 8 minus 1 divided by 3 divided by 3. You get x being equal to minus 8 minus 1, it's minus 9 over 3. Therefore, you get x being equal to 3 into minus 9, that's minus 3, which is basically the same thing. Alright, moving on to the next objective. Now, in this objective, we'll learn how to show that a function or functions are inversely related, which means that they're inverse of each other. So, how to show that functions are inverse of each other. Inversely related. Okay, so what you need to understand is this. If, say we have, okay, let me say this. Say we have f of x and g of x. If f inverse of x is equal to g of x and g inverse of x is equal to f of x, this means that these functions are inversely related. If f inverse of x is equal to g of x and g inverse of x is equal to f of x, it means that the function of f and that of g are inversely what? Related. Let's not forget. This is a condition that you should meet. Let's look at an example. So, given that f of x is equal to 5x minus 9 and g of x is equal to x plus 9 over 5. Remember, for these functions to be inversely related, f inverse of x should equal to g of x and g inverse of x should equal to f of x. The inverse of the first function should equal the second function, and the inverse of the second function should equal that of the first function. So we can just collect data and look for the inverse of f of x and g of x. So f inverse of x. So you have f of x being equal to 5x minus 9. So you let f of x be equal to y, and you have y being equal to 5x minus 9. So for x, you have 5x minus 9 being equal to y. The minus 9 goes the other side, and you have y plus 9. Divide by 5, divide by 5. X is equal to y plus 9 over 5. This means f inverse of x is equal to x plus 9 over 5. Then we find g inverse of x. We have g of x being equal to x plus 9 over 5. We let g of x equal to y. You have y being equal to x plus 9 over 5. So for x, you say over 1, and you have x plus 9 being equal to 5y. This is x being equal to 5y minus 9. Therefore, you can say g inverse of x is equal to 5x minus 9. Now, is the inverse of f equal to g of x? Let's try and prove that. So, if we try to substitute in our condition, f inverse of x is x plus 9 over 5. Is it equal to g of x? G of x is here, which is x plus 9 over 5. So it's equal. And is the g inverse of x equal to f of x? Let's try and prove. So the g inverse of x is 5x minus 9, and f of x is also 5x minus 9. Therefore, they are what? Inversely what? Related. Okay, so you say inverse of each other. Just like that. Now, if these conditions are not met, it simply means that the function or the functions to say, are not inversely what? Related. Let's not forget that. It simply means that the functions are not inversely related. Okay, so let's move on to the next objective. It should be objective 5, if I am not mistaken. Now, in objective 5, we'll try and learn how to find what are known as composite functions. Alright, so finding composite functions. So basically, when it comes to finding composite functions, it's more of applying the same knowledge that we've acquired from these other objectives and seeing how best we can manipulate in such conditions that we have and the composites. So when we talk about composite functions, we're talking about functions of another function. So functions of another function. That's what I mean. So for instance, you might come across notations like the fog of x. This simply means that you're looking for f of g of x, which can also be written as f of g of x, like that. Sometimes you could also find questions that look like f inverse, like that, of x. F inverse of g of x. This simply means that you have f inverse of g of what? X, or f inverse of g of x. That's what I mean. Alright, let us try to apply with an example or examples. Okay, so given that f of x is equal to 2x plus 1 and g of x is equal to 3x plus 2 over 4, then we need to find, let's try and find the fog of x, which is f of g of x. So now what we have to do is to understand that when we have this, it simply means that in our f function, wherever there's x, we're putting our g of x function. So which means that I have to get my f of x function, which is this guy here. Then wherever there's x, I have to plug in my g of x function. So I know I have my f of x there, I get it, 2. But wherever there's x, I have to plug in my g of x function, because it's the function of x, but wherever there's x, I put in the g of x function. So my g of x function is simply 3x plus 2 over 4, like that. But remember, I'm having a plus 1 after the x, so I put my plus 1 there. Then I have f of g of x being equal to, now this 2 multiplies the numerators only, so I have 2 times 3x, that would be 6x, then 2 times 2, that's basically 4 over 4 plus 1. Now if you want, you can just reduce this by saying 2 there, 1, 2 there, and you get some simplified values if you want. But if you want, you can just let it be like this, then you can solve it the old-fashioned way. So I have to look for a common denominator, so I say over 1, then f of g of x is simply equal to, common denominator will be 4. 4 into 4, that's 1, times what's on top, which is 6x plus 4. Then maintain the sign, which is a plus. Then 1 into 4, that's 4 times 1. Then you have f of g of x simply equal to 1 times that. Will not change anything, but 4 times 1, that will be 4 over 4. Therefore, my f of g of x is equal to 6x plus 8 over, okay, space is not enough, destroyed. Alright, so what I was trying to say is that my f of g of x is going to equal to 6x plus 8 over 4, like that. Alright, so that's how you go about it. But if you want, you can reduce. You can always reduce this. If you want, you can say f of g of x. Remember, this 4 is for 6x, so like 6x over 4 plus 8 over 4. So this will be f of g of x is equal to, so if you reduce this, it will be 2, 3, so you have like 3x over 2 plus 4 into 8, that is what? 2. So you have that. If you want, you can also look for the common denominator again, make it whole, and you might end up having something like f of g of x as this guy. If you make it a single fraction, you have to end up having something like 3x plus 4 over 2. You can always try it on your own, or you can just do it in your head and you get that. Alright, so that's how you go about it, solving this particular question. Remember, what you're supposed to do is that when I give you to find the first function, then of the second function, just get the first function that you have, and wherever there is x, put the second function. But if at all, if I have a number where there's x, what I'm supposed to do is simply just find the of x function, then plug in the input of that particular function. And that's literally how you go about it. So, you can look at another example where you will say that, let's try and look at an example where I would have something like, okay, let's make it the same. Given that f of x is equal to 2x plus 1 and g of x is equal to 3x plus 2 over 4. Say we need to find, let's say, g of f of x, and then b would be g of f of negative 2. So solving for a simply means that in my g function, wherever there's x, I'm putting the second function. So in my g function, I'm having 3. Let me not put anything, let me put a dash there. Then plus 2, then over to 4. So wherever there's x, I'm going to put the second function, which is the f function. My f function is 2x plus 1, then in brackets. Then all I have to do is simplify this. 3 times that, and by that, then g of f of x is equal to, you get 6x plus 3 plus 2 over 4. Then the GOF, or the g of f, is simply equal to 6x plus 3 plus 2 is 5. Then you get 4. After that, then you already have now your g of f of x function. Now, since I'm saying that you also have to look for the g of f of minus 2, since you already have your g of f of x, you can just get that same g of f of x function, which is 6x plus 5 over 4, and just plug in the input value being given, which is minus 2. So you get 6, then minus 2 plus 5 over 4. So you get g of f of minus 2 being equal to 6 times 2. You get minus 12 plus 5 over 4. So you get your g of f of minus 2 is equal to, if you do up your computation and check clearly what your 12 minus 5 will be, you simply get a minus 7. So you get minus 7 there over 4. And that's basically how you go about solving such a question. So different questions might be brought where they might even ask you to say find g inverse of f inverse of x, where you just have to get the g inverse function, and wherever there's x you put the f inverse function. Sometimes one could be the inverse, the other would not be the inverse, and they'll ask you to say maybe find the g of f inverse of x, which means that in the g function, wherever there's x, I'll put in my f inverse of x. It's just basically how it's supposed to, like, you just have to use logic thinking to get the answer. But it's basically the same thing. It's basically the same thing. Alright, so in the next objective, which is 6, we're going to learn how to find if a function is even, odd, or neither. Okay? So finding if a function is even, odd, not that odd, odd or neither. Alright, so let us understand the conditions. So you need to understand this. If, say we have, let's pick a random function. So if we have a function, say f of x, and it's defined to be something. So if that function f of x has some conditions, we can determine if that function is even, odd, or neither. So if f of negative x is equal to f of x, then we say the function is what? Even. But if the f of negative x is equal to negative of f of x, then we say that our function is what? Odd. But if these conditions are not met, if it's not even, if it's not odd, then it's neither. So you can also say if since these guys are the same conditions at the first place, so I can say if f of negative x is not equal to the first condition, is not equal to f of x, and it's not equal to the second condition, which is negative of f of x, then I'll say that this function is neither. So it's not even and it's not odd. It's neither. Alright, so be mindful. If f of negative x is equal to f of x, then it's even, and if f of minus x is equal to negative of f of x, then it's odd. But if f of minus x is not equal to f of x, it's not equal to minus f of x, then it's neither. But there's a shortcut. So spoiler, just look at the spoiler already. If you have the same function, say f of x, if all the powers you have of those terms, say you have x to the n, then you have x to the n minus 1, then you get something like x to the 0, which is that's like a number, a constant. So what you need to understand is this: if all the powers you have are even, then the function is even. If all the powers are even, then f of x is what? Even. Even numbers to. But if all the powers are odd, then f of x will be said to be what? Odd. Odd numbers like 1, 3, and 5. I guess most of us know what even numbers are. Alright, so let us understand this with an example. So let's say we have a question that says determine if the function is even, odd, or neither. And say we have a function f of x, let's say a is f of x being equal to 2x to the power 4 minus 4x plus 5. Alright, let's try and solve this. So let's try and check if it's even. The condition states that if f of negative x is equal to what? F of x, then it's even. So wherever there's x, let's put minus x. So we have f of minus x would be 2 of minus x to the power 4, then minus 4 of minus x, then plus 5 should equal to f of x, which is 2 to the x to the 4th, which is 2x to the 4th, sorry, minus 4x plus 5. So if I, let's just simplify this, I'll get, since this minus x is raised to an even power, then my sign, sorry, will be positive. So I'll get x to the 4th, but since this one is raised to a 1, which means I get a negative, so minus 4 times minus x will give me a plus 4x plus 5. and this is basically not equal to 2x to the fourth minus 4x plus 5. So we say not even. Let's try and check if it's odd. For it to be odd, f of minus x should equal to minus f of what? X. So f of minus x, we know what we're doing. We're going to put a minus x wherever there's x. So we have 2 minus x to the fourth. Then minus 4 minus x plus 5 should equal to minus of everything you have. 2x to the fourth minus 4x plus 5. So this will be 2x to the fourth. Then this times that will be plus 4x plus 5. The negative times everything. Negative by that, and by that. You get minus 2x to the fourth plus 4x minus 5. So basically this is not equal to this portion here. So it's not. So therefore not odd. So basically it's not even and it's not odd. So it's neither. So we'll say that this implies that f of x being equal to 2x to the fourth minus 4x plus 5 is what? Neither. Now, remember what I said, the spoiler, the shortcut. Just check the powers you have. You have x to the power 4, then minus x, then you're having a constant. Because you're having a constant, it means you have plus x to the power 0. So in a case where you have the powers, some are even and some are odd, it simply means that what you have is neither. Because for it to be odd, all the powers should be what? Odd. And for it to be even, all the powers should be what? Even. But you have a combination of even, then you have odd, then you have even, which is a combination. That's why it's what? Neither. But if I had 4, 2, 8, it would have been odd. Let's not forget that. So, let's say we have f of x being equal to 5x to the power 3 minus 4x. Now, from inspection, have you seen the powers that we're having? We're having x to the power 3, then x to the power 1. 3 and 1 are odd numbers, so expect this to be odd. So let's try and prove it. So let's check if it's even. So f of minus x should be equal to what? F of x. So wherever there's x, I'll put minus x. So 5 minus x to the third minus 4 minus x is equal to 5x cubed minus 4x. So this, any negative value raised to an odd number, you always get a negative value. But if you raise it to an even, you get a positive value. So this will be minus 5x to the power 3. Then minus 4 times minus x, you get plus 4x. And this is basically not equal to 5x to the power 3 minus 4x. Therefore, not even. But if I want to test if it's odd, I'll just have to apply the condition. It should give me minus f of what? X. So I'm going to put x wherever there is that. So I'll have 5 minus x to the third minus 4 minus x. So I get minus x there. Then it's equal to minus of everything I have, which is 5x cubed minus 4x. So this would be minus 5x cubed plus 4x. And if I multiply minus by everything inside, I get minus 5x cubed then plus 4x. So you find that minus 5x cubed plus 4x is the same as minus 5x cubed plus 4x on the other end. So this simply means that the function I'm having, so say therefore f of x being equal to 5x cubed plus minus 4x is odd. Then using the inspection method, remember, just get the powers you're having, that, then x to the 1. So this is odd, this is also odd, therefore it's odd. Alright, so basically that's how you go about showing if it's even, odd, or neither. So in this video, we'll just look at these objectives, but be ready for the next objectives that will be produced in the next videos. Remember, if you have a question, you can always reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let us always strategize so we cannot become a statistic. Let's try to push for that a plus.